Okay, so we noticed some relationships between what happens with the original and the reciprocal. We'll see if that holds true with the quadratic. So we'll go through again. We're going to do this relatively quickly. So I know this graph is 0, 0, 1, 1, 2, 4, 3, 9, negative 1, 1, negative 2, 4, negative 3, 9. So there's 1, 1, 2, 4, 3, 9. So 5, 6, 7, 8, 9. Same in the negatives. Okay, so we know lots about that. Graph that we probably haven't looked at is a reciprocal, which is 1 over x squared. So we're going to get these numbers, instead of actually doing the math, we're going to get them right from the original here. So we're going to look at each value, and we're going to take the reciprocal of the y value, because it's going to be exactly the same. So at negative 3, it was 9, so this becomes 1 over 9, right? The reciprocal, flip it. It used to be 4, so now it's 1 over 4. 1 is 1 over 1. 0, well, what happens to that? Of course, we're going to get an asymptote. 1 over 1 is 1. 1 over 2, again, we could plug it in as well. 2 squared is 4, so it's on the bottom, so it's 1 over 4. Or you can just look at this and say it was 4 here, so the reciprocal is 1 over 4. And the last one's 1 over 9. So I'll graph those ones. I already see that at 0, I'm going to end up with an asymptote. And I'll start graphing some of the points. So 1, 1. 2 and 1/4, so that's way down here, and then we get really close to 1/9. Vice versa in the negatives. Negative 1, except this goes to the positive 1 because we're squaring the number. Negative 2, it's 1/4, so it's down here. Oops. And 1/9. Now we're asked to look at the 1/2. So 1 over 1/2 is on the bottom, but it gets squared. So it becomes 1 over 1/2 squared. That's 1 over 1/4, which is the same as 1 times 4 over 1, which is 4. Same for the negative, so I get plus 4. What's 1 over 1 cubed squared? Or sorry, 1 over 1/3 squared? Well, the 1/3 squared becomes 1/9, and it's 1 over 1/9, so the reciprocal of 1/9 is 9. Same with the plus or the minus. 4 squared is 16. So it'll be 1 over 16. But then the reciprocal of that is 16. So when we graph these, we start to notice the same sort of pattern here. 1/2 goes up to 4. 1/3 is up to 9. And then the 16 is off the graph. Same thing in the negatives. Negative 1/2 gets to a positive 4 because we're squaring. And negative gets to 9. And so this graph actually looks like this. So we know some connections between the original linear function and its reciprocal. Let's see if some of those same patterns hold true with the quadratic and its reciprocal. So in the last one, let's actually go split screen here and see if we can compare what we did before. So we see here when the original was 0, what results in the reciprocal. So in this case, when the original was 0, we got an asymptote. So over here, when the original is 0, right there, what happens to the reciprocal? Well, of course, we get an asymptote again. And that's because when you take the reciprocal of 0, you get 1 over 0, and then you can't have that. So we end up with an asymptote. When the graph is positive, well, with the original, the whole thing is positive, and guess what? The reciprocal is all positive, so that's good. There is no vice versa in this one because there's no negatives. Now, but what about when the graph increases? Well, in this case, it's only increasing on the right-hand side. And what happens to numbers? So like the numbers 1, 2, 3, 4, when you take the reciprocal, those become 1, 1/2, 1/3. So when it increases, the reciprocal is going to do the opposite. It's going to decrease, and we see that happening. Vice versa, sure, the original is decreasing, so when you get numbers smaller, you take the reciprocal of those, they get bigger. But anyway, we're just looking at the increasing, so this decreases. And then vice versa. When the original is at 1, the reciprocal is at 1 because the reciprocal of 1 is 1. And now here's the interesting part. Remember in the last one, we had a y-intercept of 0, and of course when you take the reciprocal of 0, you get an asymptote. The only difference on this, well, this one we end up with a 0 as well. So we'll have 1 over 0 again, doesn't exist. And if you look at our graph, of course, there is no y-intercept because there's an asymptote. And this one also has a horizontal asymptote at y equals 0, just like in the other ones. So what we're going to do now is, first off, we notice that all the patterns that happened with the original linear function, the reciprocals, hold true for the quadratic. So I'm going to skip ahead on this and show you the answers to the next one. So you'll have to find some time to finish these graphs, but I want you to notice that all of these are going to be the same. All these patterns are going to be the same. We have an original function. This is a straight line, except this one's going down. And we end up with some sort of rational expression over here. The one part that's really, really interesting is right here. So we're just going to fill in this part, and I'll leave the rest for you to fill in yourself. This graph, this linear graph, has a y-intercept where? Well, a y-intercept is at 2. And what's the reciprocal of 2? Well, it's 1/2. Let's check the graph to see if this has a y-intercept of of 1/2. Yes, it does. So that's good. It also has an asymptote at y equals 0. It looks like all of these have had an asymptote of y equals 0. Okay, so there's your asymptote at y equals 0. The one thing that is different, that maybe I'll do in black here, is that this asymptote here has been shifted over. So I wonder why that is. Well, that comes to the first spot right here. When the original is at 0, where's the original at 0? Well, it happens to be right here. So at x equals 2, so this is at x equals 2, the original has an asymptote right here. Sorry, the original touches 0. This has an asymptote at x equals 2. Because if the original value was 0, right here, the reciprocal is not going to exist. So this has an asymptote. So that's a key learning in this part. If you have a y-intercept in the original, then that's going to result in an asymptote. So here's the y-intercept in the original. That's going to result in the asymptote of the reciprocal. If we look ahead at the next one, again, I've already done this, so you'll have to find some time to do this on your own, but that key idea right there, look at right here. This one has 2 intercepts, right here and here. So what happens on those? Well, there's an intercept at x equals -2, an intercept at x equals 2. Why is it? Well, you put in -2 squared minus 4, that's going to be 4 minus 4 is 0. Same thing with +2. So these ones, when the original is at 0, guess what happens in the reciprocal? Right there. We end up with an asymptote here and an asymptote here. So we have, in this case, we're going to have 2 asymptotes. So we haven't seen any graphs that look like this. But it's all based on this idea that if the original crosses through 0, you look at the reciprocal, 1 over 0 is not going to exist. All the other patterns still hold true. As this decreases, this graph increases. Here's y-intercept. The y-intercept is at -4. What's the reciprocal of that? -1 over 4. Oh, look, right there. It's kind of tiny, but it's right there at -1 over 4. And the last thing, this also has a horizontal asymptote at y equals 0. So all of them have had horizontal asymptotes at y equals 0. So we're going to take all these and see if we can't do one brand new sketch all by ourselves.